In this video, we're going to be working once again with our interior scene in order to create another GI solution, this time using V-Ray's Light Cache engine, using of course the same basic procedure as with our previous irradiance mapping exercise. First thing we want to do then is open up the options editor, and in the GI rollout, set Light Cache to be our primary bounce engine, whilst once again setting the secondary engine to none. Now, the default Light Cache settings that we have, as with irradiance mapping, are designed to give us a fairly decent level of quality from the system. Although, of course, the settings here are assuming that we are using Light Cache in its more suitable role as a secondary bounce engine. If we go ahead and take a render though, we will see a couple of things. Firstly, that we do get a very high level of illumination in our render, certainly much brighter than was the case with our initial irradiance map only solution. This is because Light Cache rays, like their parent technology photons, automatically perform multiple light bounces in a scene, and they do so very quickly indeed, which is in fact Light Cache's big strength. We also see though that even with a reasonably high subdivision value of 1000 set, we are still getting a very blotchy looking render, meaning we would obviously need to improve the current Light Cache quality settings before we would be able to get a good looking and so usable lighting solution from it. What though about enabling the same sky portals that we used in our irradiance mapping exercise? Well, let's go ahead and unhide those from the layers dialog and give them a try. Now, we have already in this version of the scene set these up to function using the portal light mode. That being the case then, we can simply go ahead and after saving what we have to the history list, take another render. An examination of the two renders side by side shows that what we have now is certainly brighter in terms of illumination inside the environment, and we could even say that the solution does look a little bit smoother, meaning we've probably made enough of a difference here for it to be worth our while leaving the sky portal as enabled. What we couldn't honestly say, however, is that we've cleaned up our GI solution in any kind of a meaningful way. One thing we perhaps could do then is come to our Light Cache controls and increase the subdivisions parameter. Let's try quite a significant jump and go all the way up to a value of 3000, keeping in mind here that in terms of actual samples or rays being used, this should really read as 3000 multiplied by 3000 samples, meaning we are now producing a total of around about 9 million Light Cache rays in the scene. And yet, even so, if we save what we have and take another render, we see that whilst what we get does look much smoother in terms of general noise and still doesn't take that much time to render considering we are using a higher sample count, the simple truth is that a quick comparison shows us that the averaging or blending of samples that Light Cache automatically performs clearly causes us to lose more and more geometry detail in our render. Again, we really wouldn't want to use this as a final lighting solution in our scenes. We could perhaps improve matters a little by tweaking both the pre-filter and interpolate samples options, but again, neither of these would really bring us to the point of being happy to use this Light Cache setup as our primary GI lighting engine. In fact, unfortunately, the simple truth is that the Light Cache system just isn't, typically speaking, a good choice for use in the primary engine slot. Unless, that is, we make use of a unique operating mode of the Light Cache engine and set it up to perform as a progressive path trace system. This essentially is a brute force way in which we can reconstruct and render light energy found in our environment. The beauty of this setup being that there really are no quality parameters at all that have to be tweaked once we have things up and running, that is, and even the setup of that is extremely simple. All we need to do is come to the Mode drop-down and select the Progressive Path Trace option. If we want to get an unbiased render from V-Ray, we do need to set our sample size to 0, and then all we have to do is use the subdiv parameter to essentially control the quality that we want from our final image. If we take a render now, what we initially see appears to be a typical Light Cache pre-calculation in progress, but it actually isn't. What we are seeing here are the final pixels in this image being rendered. In other words, this is not a GI lighting solution that we are looking at, this is the final render. Of course, with the current subdiv settings, which are in fact quite low for a progressive path trace render, we do get quite a lot of noise in the scene, and so we would really need to increase this if we wanted to produce something that looked reasonably decent at the end of the day. In fact, if I just hit the Load Image button on the V-Ray frame buffer and navigate to the Exercise Files and Images folder, I can open up the O3_03_LC progressive file, where you can see the render that we would get if I used a subdiv value of 15,000 here. Now obviously this image had a much higher render time than is normal when using the Lightcache system, but we have produced, as you can see, a really nice looking lighting solution that picks out lots of geometric detail found in the scene, and as we say, done with almost no parameter tweaking at all. In conclusion then, we have been able to see in this exercise why Lightcache is not oftentimes used as a primary bounce engine, given that the solutions it produces can be both soft and blotchy, even when using fairly high subdiv counts. We have at the same time though noted that if we do want to use Lightcache as the primary bounce engine, then we can enable progressive path trace mode and actually get a really nice, almost tweak-free GI render from the system.